Assalamu alaikum everyone. Today I will explain Rolle's theorem in a differential equation. I have explained some derivative formula, basic rules and derivation and examples also. Second order derivative in last class I have explained second order derivative. Now today I will teach you Rolle's theorem. What is Rolle's theorem? First write a statement, then I will go for derivation of the Rolle's theorem. First statement. Let f from a closed interval AB into R. Let f from closed interval AB into R be continuous and continuous on closed interval AB and differentiable in open interval AB. What is given? Let f from A to B, a closed interval A into AB into R be continuous on closed interval AB and differentiable on in open interval AB, where A and B are such that there is one condition such that what is that? Such that f of A equal to f of B, f of A equal to f of B. If f is continuous on closed interval AB and differentiable in AB, then just that f of A is equal to f of B. Okay. Where A and B are some real numbers. Where A and B are some real numbers. Okay. Then there exists a point. If this happens, then there exists a point C, then there exists a point C in AB such that, again we have one condition, such that f dash of C is equal to 0. Okay, what is given? F is a function from a closed interval AB into R. R is nothing but a real number, set of real numbers. This function is continuous on closed interval AB and differentiable in the open interval AB, such that if f of A equal to f of B, if both are equal, f of A and f of B, both functions are equal, then we can say that f is continuous on AB, closed interval AB, and differentiable on open interval AB, where A and B are some real numbers. A and B are real numbers. Okay. Then there exists a point. If this happens, if this condition satisfied, then there exists a point C in AB. There exists a point C in between AB, A and B, in between AB, such that f dash of C is equal to 0. This is called Rolle's theorem. Now, I will show you the derivative of Rolle's theorem. Now, draw figures. Consider here slope of tangent. This one is the origin O, X, X dash, Y, Y dash. Okay. Now draw one curve like this. Where this point is A, this one is B, and the top of this curve is nothing but point C. The point, there exists a point in between A and B. So this one is slope of the tangent f of C. This is the function f of C. Okay, we have one figure. Draw another figure. I will explain you the graph of this. By using the graph, we can write this theorem. Okay, x, x dash, point O is the origin here, y, y dash. Okay, now here, see here, this one is one curve lies in y dash and another is lies in x dash. One point is in y dash. This one is point A. This one is point B. Point A, point B. Name these as figure 1, figure 1, and this one as figure 2. Okay, see here. In both the graph, we can observe that the slope of the tangent to the curve is varies in between point A and B. The slope of the tangent to this curve, this slope is varies in between point A and B. This is the value. The f of x is nothing but we are taking f of x as f of c, and the slope of this function is varies in between the point A and B. And in between point A, B, there exists a point C. And the value of this slope, it will become 0 at least one point. In both the curve, the value of this slope of the tangent, the slope value will become 0 at least one point. If we increase this curve slope, then it will become 0 here. If we go, I will show you here. If we are taking like this, it will become 0. So at least one point, the value of the tangent or the slope of this curve will become 0. Here also same. The points are in the first figure, both points lies on x-axis. That's why we have slope like this, and the slope varies in between these 2 points A and B. And there exists a point C where we have top of the curve slope of the tangent as f of c, and it will become 0 at least one point. Okay, now in the second figure we have points, one point in y dash axis and another point in x axis. So same here, the slope value will become 0 at least one point. Here it will become varies, it will become here like this, it will become 0. So at least one point, the slope value will become 0. So this is why, because we are taking here real numbers, set of real numbers, that's why we claim that slope value will become 0 at least one point. So we can say the slope of the tangent to the graph. This graph is nothing but we are using here which graph? f of x I am writing. The slope of the tangent to the graph y is equal to f of x. We are taking this graph. This graph is y is equal to f of x. Here we got point C in between AB. That's why we wrote here, I have wrote here f of C. Okay. So the slope of the tangent in the graph is y is equal to f of x. It is nothing but the derivative of f of x. Derivative of this function. Derivative of this function is y dash is equal to f dash of x. So what we will get here by these two graphs? The value of the value of the function varies in between a and b. So we can say that we will get the derivative of the function. The variation of the point, if we vary the point, then we will get different values of f of x. Or that's why we can say that this is these two graphs by seeing these two graphs, we can say that this is nothing but the derivation of the derivative or the differentiation of f of x. So that's why we got f of x is the function of f of x is y is equal to f of x, the graph of this graph. So as the points increases, the values varies in between a and b, in both the graphs. So we can say that the given function values are different. That's why we are differentiating function. So it is known as the derivative of f of x. Okay. Now I will show you some examples. Once again I will repeat. It's very simple. How to remember this is we are taking one function. How to remember the statement? First, we are taking one function f, which is in between closed interval AB to a real number, set of real numbers. Okay, and it is continuous on closed interval AB and differentiable in open interval AB. Okay, so this is symbol for closed interval, closed bracket, and this open bracket is for square bracket is for differentiable. That's it. What is if the function satisfies this condition f of a equal to f of b, then we can say that this function is continuous on closed interval ab and differentiable in ab. Okay. Now where a and b are some real numbers, we are taking set of real numbers. Then there exists, if this condition satisfied, then there exists a point C in AB such that f dash of C is equal to 0. F dash of C is nothing but the derivation of the function f of x which is given to you. Okay, now again I will explain once again. Don't get confused. We are taking a graph which is y is equal to f of x, x dash, and y dash O is the point origin. So see here, the value of f of x is varies. The slope of tangent to this curve is varies in between the point A and B, and there exists a point C in between A and B. Okay, and we can see that here we can observe the value of this slope of the tangent to the curve. The slope value will become 0 at least one point in both the graphs. Okay. So what is different in between these two? Here we are having A and B on the same axis, x-axis in positive direction. In the second graph, we have point difference. A is in y-dash axis and B is on x-dash axis. X-axis. Sorry, x-axis. Okay, and here also the slope will become 0 at least one point. This shows that this is nothing but the values of the given function is changes as the point changes. That's why we can say that this one is the derivative of the given function, or we can say the differentiation of the given function f of x. The differentiation of f of x is f dash of x. This is known as the Rolle's theorem. Okay. Now I will show you some example based on Rolle's theorem. Okay, write down examples. If you have any doubt in this Rolle's theorem explanation, it is very simple. If I have explained two or three times, if you have doubt, you can ask me. You can send me a message. I will explain it once again. Now I will go for the example. Let's solve some example based on this formula. It's very easy to find this examples also. Example also very easy. Write down example to verify the Rolle's theorem. Rolle's theorem is nothing but the derivation of the differentiation of the given function by using the graph. Now write down example. Take example based on the Rolle's theorem. Verify Rolle's theorem. For the given function. Verify Rolle's theorem for the given function fy is equal to x square plus 2. What is given? A and B. The 2 point is given to you. A is minus 2 and B is plus 2. This one is 2. So what is given to you? A function is given to you, y is equal to x square plus 2x. We can take y as f of x. Okay. And 2 point is given to you. A is minus 2 and B is plus 2. Now write solution. Write solution. Given what is given to you. Write first y is equal to x square plus 2. We can take this y as f of x is equal to x square plus 2. Okay. What is the condition in Rolle's theorem? The given function is continuous on closed interval AB and differentiable in the open interval AB if f of a is equal to f of b. What is given here? A is minus 2, b is plus 2. So we have to find f of a and f of b. So now f of a is here minus 2. So substituting wherever you are having x, replace x by minus 2. Minus 2 square plus 2. Now it will become minus 2. 2 to the 4, minus into minus will become plus. 4 plus 2 is equal to 6. Okay. Now go for f of b. F of b. B is plus 2. So whenever you are having x, replace this x here in f of x. Replace x by 2. Okay. 2 square plus 2. 2 to the 4. 4 plus 2. 4 plus 2 is 6. F of b. Okay. We got f of a, f of b both same value 6. So right here this implies f of a equal to f of b equal to 6. Okay. Now we can say that the given function f of x has the same is coincides in the given function f of x is coincides at the point a equal to minus 2 and b 2. So we got same value f of a and f of b both are same and it is 6. So we can say that the given function f of x is coincide at the point -2 and 2. Now we have to find what is the another condition in Rolle's theorem. We have two conditions in Rolle's theorem. First is f of a equal to f of b. Then we can say that it is a continuous and differentiable function. F of x is continuous as well as differentiable function. Now we have to find what is the another condition in Rolle's theorem. There exists a point C in between A and B. There exists a point C in between A and C, such that f dash of C is equal to 0. So we have to prove the second part of this one is the first part of Rolle's theorem. Second part of Rolle's theorem I am continue writing here. For the second part, we have to prove that there exists a point C in between A and B. Okay. Now what is given to you? F of x is x square plus 2. X square plus 2. Okay. Now find the derivative of this function. F dash of x is differentiation of f of x. Differentiation of x square is 2x by using x raised to n formula. Differentiation of x raised to n formula. Differentiation of x raised to n into a differentiation of n minus 1. N into x raised to n minus 1. So 2 minus 1 is 1. So 2x. Plus differentiation of constant is 0. That's why the derivative function differentiation of f of x is 2x. Now we have to show that there exists a point C in between A and B. So consider the point, let x is equal to 0. Suppose x is equal to 0. Then f dash of x become f dash of 0. Replace x by 0. F dash of 0 is 2 into 0. 2 into 0 is 0. 2 into 0 is 0. So we got f dash of 0 as 0. So we can say that f dash of c is equal to 0. Means I am taking c as 0 because f dash of c we got if we take x value 0, then we will get f dash value is 0. So if f dash of x is 0, then we can say that there exists a point C in between A and B. So 0 is in between A and B. So how we can say 0 is in between plus 2 and minus 2. On the real number, we will get 0 here and plus 1 plus 2 minus 1 minus 2. Okay. So C is nothing but here. C is point 0 is C. A is 2 plus 2 and B is minus 2. So we got point C here. By taking x value 0, we got f dash of C as 0. That's why C is the point. There exists a point C in between A and B. So this point is 0 is the point which is in between A and B. So that f dash value will become 0. Then there exists a point. Now write one sentence here. There exists a point C in plus 2 and minus 2 such that x is equal to 0. By taking x 0, we got f dash value as 0. That's why C is the point in between and so this satisfied the Rolle's theorem. Hence proved. So we can write one sentence here once again. Hence there exists a point. Each point there exists a point 0 belongs to 2, minus 2. Sorry, first function is minus 2. That's why take first function First point is minus 2 and second point is plus 2. It is given a is minus 2, b is 2. So write first function minus 2 and second plus 2. So it is very simple. What is given to you, right? Find a and b value is given to you. Find f of a and f of b. If both are same, then you can say that given function is continuous and differentiable on that point. Okay, now for the second part of Rolle's theorem, we have to find a function. There is just a point function p in AB such that f dash of p is equal to 0. That's why we have to take x is equal to 0. On this point, the value of the derivative function f dash of p will become 0. That's why p is the 0 is the point in between minus 2 and 2. Now take another example. Same. Verify Rolle's theorem. If you have see here, if you want to write, you can write solution also. Write another example. Verify Rolle's theorem. If in Rolle's theorem verification, we have to find solution in two parts. One, we have to show that f of a equal to f of b. Another, we have to find a function where the derivation differentiation of that function will become 0. Write another example. Verify Rolle's theorem at y is equal to x square plus 2x square plus 2x minus 8 at what is the point? Point is given to you as a is minus 4 and b is plus 2. Point is given to you as a is minus 4 and b is plus 2. Function is x square plus 2x minus 8. Okay. Now write down solution. Solution. First write given. What is given to you? Y is equal to x square plus 2x minus 8. Okay. Now find f of a and f of b. Take this one as f of y. We can take y as f of x. F of x is equal to x square plus 2x minus 8. So a is minus 4. Take let x equal to minus 4 because it is given to you a value as minus 4. So this implies f of minus 4 is wherever you are having x, replace x by minus 4. Minus 4 square plus 2 into minus 4 minus 8 is equal to 4 4s are 16. Minus into minus will become plus. Plus 16 minus 4 2s are 8. Minus this one is remaining 8. So it will become 16, 8 minus 8 minus 16. So it will become f of minus 4 value is 0 here. Now finding let x equal to 2. X equal to 2 here. F of 2 is we have first write f of x, don't get confused, write f of x as x square plus 2x minus 8. So now let x equal to 2, then f of 2 is 2 square plus 2 into 2 minus 8. 2 2 are 4 plus 2 2 are 4. 2 square is 4 and this one is 2 2 are 4 minus 8. So here 4 plus 4 8. 8 minus 8 it will become 0. F of 2 is 0. This implies f of minus 4 is equal to f of 2 equal to 0. Both we got 0. Okay. So the function f of x has same value at the point the function f of x coincide at the point minus 4 and 2. So this is the first part of Rolle's theorem where we have proved f of a equal to f of b. Okay. Now go for another point where we have to find the function a point c in between a and b. Okay. Now let f of x is given to you as f of x is x square plus 2x minus 8. F of x value is given to you. Okay. Now find the derivative of this function f dash of x. F dash of x is x square differentiation is 2x and 2x differentiation is 2 plus 2. Okay. Now we have to take one function, one point x as such that f dash of x becomes 0. We have to choose one function, one point. We have to replace this x by the value such that f dash of x will become 0. And that point lies in between 2 and minus 4. Now let x equal to minus 1. Okay. What happens here? F dash of minus 1 equal to 2 into minus 1 plus 2. Now open this bracket. 2 ones are 2 plus into minus minus 2 plus 2. So this plus and minus 2 get cancelled. Then we will get f of minus 1. F dash of minus 1 are 0. So this f dash of minus is nothing but c. This implies this point minus 1 is nothing but c. We got point c, which is lies in between 2 and 4. In the real number we can see, the line of the real number we can see this one is 0, plus 1, plus 2, minus 1, minus 2, minus 3 and minus 4. This minus 4 is A, plus 2 is B, minus 1 is C here. So C is lies in between A and B. And f dash of C is equal to 0. According to Rolle's theorem, we got this implies f dash of C is equal to 0. This is the second part of the Rolle's theorem. First part is we have to show that f of A equal to f of B. We have got f of A equal to f of B. We got both are same as 0. Here f of x is given to you. Find the derivative of this function. Now substitute. We have to choose how to choose the value of x is important here. We have to choose the value of x such that this value becomes 0. By substituting x value as minus 1, you will get this f dash of x as 0. That's why c is minus 1. And we can say here there exists a point. Here we can say this is only for your understanding. Now write there exists a point C belongs to AB. It is according to the theorem. Now we got value as -1 belongs to A is 4, -4 and B is -2. There is just a point -1 belongs to -4 and -2, 4 and 2 where f dash of C equal to 0. Okay, or we can say f dash of -1 equal to 0, hence okay. So with this I will stop. In the next class, if you have any doubt, you can actually ask me, and try to understand this first, the statement of the theorem by using the graph and the examples. If you practice this example 10 15 times each example, then inshallah you will be perfect on this, and you can solve as much as example. If only function is different and number is different given to you, only function value is different and the value of the given point is different, it's given in the another example. So if you will be perfect in one two example by practicing it at a daily basis, on the regular basis, if you practice, then you will become perfect inshallah. If suppose if you have any doubt in the Rolle's theorem explanation or the example of the Rolle's theorem, or you have another problems, or you have another problems or any other examples, you can send me. I will show you the solution of that problem. Okay. Thank you. Inshallah, in the next class, I will explain the mean value theorem, which is extent of the Rolle's theorem. Okay. Thank you.